Uh, in today's video, we are going to see how we can plot a parabola given by this equation on an xy plane. Uh, we will see what effects do A, B, and C have on this parabola. So let's get started. We will use an example like y is equal to x square minus 5x plus 6. This is an example, but it will kind of the methods that we will see will apply to any kind of parabola. So let's get started and draw an xy curve here, and then try to see what is the effect of A on the parabola. So to do this, we will take a very simple example. Y is equal to, let's say, 4x square. Now if 4 is positive, the parabola is upwards. If 4 is negative, the parabola is downwards. The reason for this is the sign of A will tell if the parabola is upward. The reason for it is, for a very large value of A, if A is positive, for very large value of x, if A is positive, the parabola is always going to have a positive. Or even for a very large negative value, this is the dominant term, will always going to be positive. In the same way, if A value is negative, then parabola is downward. So A determines the shape of the parabola, whether it is upwards or downwards. The next thing you need to keep in mind is that if for a same different values of a parabola is going to look like this, or a parabola is going to look like this. If these are the two cases, then for a given value of x, this one will have a smaller value of y and this will have a larger value of y. This means that in this case, a is larger. For example, if this is y is equal to 4x square, then this could be like y is equal to 6x square, showing a larger value of y. And similar thing we can show for the other parabola. Now with that said, let's move on to the next variable, which is c. How is c playing a role in this parabola shape? So let's delete all of this and make a clean sheet. We notice that this, if in this equation, if when x is equal to 0, y is equal to 0 into x square plus b into x plus c, so y becomes c. So c represents the intercept on the y-axis. So if this is the parabola, and if this parabola is going to cut this thing in like this, then c represents this intercept of this thing. In this case, this equation, this curve must cut this y-axis at some point. There is absolutely no way it will not cut. It may touch it at 0, for example, in case of like this. It may cut it like this at negative, or it may cut at positive in different way, but it certainly must cut the y-axis. In case it cuts at the, let's say, in the center, then the value of c will be 0. The curve will look like y is equal to ax square plus b, or maybe just ax square. So c represents the intercept of this parabola on the y-axis. Now let's take a look at the next thing, and what role does b plays, and for that we will look at this example as an example to find out what is the value of b. So let's take a look at this particular example, in which case we know that this equation has a y-intercept of 6, and this parabola is an upward going parabola. So there are two possibilities. This curve may look like this, in which case this being the 6 being the intercept on the y-axis, or it is possible that the curve could be looking like this parabola, cutting the y-axis again at the unit distance of 6. The question is, which of these two represents this curve? Whether it is shifted towards the positive x-axis or it is shifted towards the negative x-axis. And for this there is a simple, very simple rule to remember. This thing, the B, represents the slope of the curve when this is, let us say this is the parabola, and I draw a line just touching this, is tangent at this point. Then the slope of this line is B. In the same way, if this is the curve cutting this y-axis at this point, and if I draw a slope here, then this slope is given by B. In this case, the slope is negative, and that is possible only when this is the curve. So the curve has to be shifted towards the x-axis. So in overall, what our the line could be looking like, this must be our line, this must look like something like this. This being the 6 being the, and here we know that if I draw a tangent, the slope of that tangent is negative. That is given by this one. Now there are few more things you need to find about this parabola. In some cases, it's possible that this curve may not cut the x-axis at all, like this one. It may cut the x-axis at two different points, like this, or it may cut the axis at one single point. These are the three possibilities, and in order to find out what's going on, we will have to factorize this. Either factorize it or use the quadratic formula to find the two roots of the equation. So let's factorize it and see what's going on. Y equal to x minus 3 into x minus 2. If you do not know how I factorize it very quickly, you have another video of this. This means that y is equal to 0 when either this is 0 or this is 0, which means either x equal to 3 or x equal to 2, which means that it cuts this x-axis at x is equal to 2 and x is equal to 3. In some cases, this parabola may not cut the x-axis at all. For example, if I take this equation, y is equal to x square minus 5x plus, let's say, 21, in that case, it will not cut the x-axis at all. As you can see that by making this 21 larger, the parabola starts shifting upwards, and you can use a very nice tool called Desmos to visualize this. What happens is, in this case, if I try to find out the roots of x using the formula minus b plus minus square root of b square minus 4ac upon 2a, then this thing b square minus 4ac becomes 25. This is 25 minus 4 into 21, and this becomes negative. And when this becomes negative, the parabola will look like this. And when b square minus 4ac is 0, the parabola will be touching the x-axis. So the roots of this equation will tell you, does it cut at 2 points? In that case, what are those 2 points? And if it does not cut the x-axis, then you will also know it using b square minus 4ac. And finally, you can find out the maxima and minima of this curve. Where does it occur? In two ways. One is by using the formula minus 2b by a. At this point, the curve will have at its maximum. I will strongly encourage you to take an interest into calculus, which makes such things very easy. But there are other ways as well to find this maxima and minima. One way, for example, is we know that it cuts the x-axis at these 2 points. So the maxima and minima, or the minima, will be half of this at 2 plus 3 by 2 is equal to 2.5. And that this is the point where it is at, will get a minima. The other way is to make it a perfect square. I can write it as x square minus 2 into 5 by 2 into x plus 5 by 2 whole square and plus 6 minus 5 by 2 whole square. And then this I can write it as x minus 5 by 2 whole square and plus rest of the term, which is 6 into 4 minus 25 by 4. We know that this value can only be as much. Actually, this is some mistake here. 2 into this is going to be 2ab. This is 1 by 2 whole square. So this will become 4 minus 25. So eventually this value is going to be a negative value. So this whole thing will have a lowest value of this much, because this is always going to be positive, and we find out that that value of x is minimum at x equal to 5 by 2. So this way you can find out where is the peak value of y and what is that peak value by substituting x equal to 5 by 2 into this equation. So I touched upon some of the topics to see how you can visualize a parabola and plot it. Thank you.